So still only 25 have joined the class. So what's going on with the afternoon classes? Okay, strength is very getting down. Right. So we'll be referring the classes. We'll see whether some more strength are going to be adding with the class. Right. So we'll be discussing with the previous class. So the previous class is related with the GSM architecture. We've been discussed already with the GSM services. What are the three categories of the services that are provided by the GSM? And we mainly discussed about the GSM architecture. And the GSM architecture is being used by 800 million people around the globe, and right from the 190 countries, they are being using this particular GSM architecture and GSM technology for our mobile computing devices. So what this GSM is consisting of, what are its services, already we discussed about it. And coming to this architecture, it is going to be providing the bearer services, tele services, and also the corresponding supplementary services relating to the both the bearer and the tele services. So what about this GSM architecture? So what architecture it is having in order to serve us with that sort of services, that sort of bearer services are there, what is called as tele services are there, and we are also having the corresponding supplementary services. In order to provide that particular services and how it has become popular with all those services, what sort of architecture it is having, that's what we discussed in the previous class. So that particular GSM architecture, what we are seeing on the screen, consisting of the three subsystems. Radio subsystem is there, radio and what is called as radio RSS, and NSS, network and switching subsystem, is there for us, and OSS, operating subsystem. Right. So the RSS is there for us, NSS is there, OSS is there. Its total architecture has been categorized into three subsystems, and RSS is concerned with all the mobile stations that are being divided into the radio cells. All the mobile stations are being divided into different radio cells according to the coverage of the signal of that particular base transceiver system. So how the particular base transfer system is going to be covering its signal, and it is how much of mobile stations it can be get coped up with, and it is being connected with, its radio cell will be get divided. So a particular radio cell is going to be consisting of a group of mobile stations that are being communicating with the base transceiver station. Okay, the base transceiver system, and all those radio cells are going to be get grouped in a single BSS. A single BSS, that is nothing but the base station subsystem or base station subsystem or base station system, is going to be consisting of group of radio cells, within which all those radio cells are going to be consisting of group of mobile stations, and all those mobile stations are going to be communicating with the base transceiver system, and all these are going to be right, comes under or getting controlled by the BSC, that is base station controller. Okay, so this base station controller is going to be controlling a single BSS consisting of a group of radio cells and consisting of a group of mobile stations, and also the corresponding base transceiver systems. So that whenever the corresponding subscriber or user is going to be raising a call, or he's going to be operating with the mobile computing device, he has to start as, or he will be considered as the mobile station. And from that, the signal will be reaching the base transceiver system. From the base transceiver system, the signal will be get exchanged with the base station controller. So thus the signal from the mobile station is going to be get interfaced with the UM interface to the base transceiver system. From the base transceiver system, using A-bin interface, we are getting controlled with the base station controller. So from there onwards, the signal will be getting outside of the BSS. So from the base station, base subsystem or base station system or base station subsystem, the signal will be getting out of its BSS through the BSC. That is a base station control. So from there onwards, the signal will be get connected with the mobile station control or the master switching center or mobile switching center connected with the network. So how you are being connecting to the network first for our communication lead. For our communication purpose, how you are connecting to the network? We are connecting to the network with the means of BSC itself. So to where the BSC is being connected to, the BSC, there is nothing but the base station controller will be getting connected to the mobile switching center. So through this mobile switching center, we are being connecting with the help of an interface called as A with the network switching subsystem. With the network switching subsystem, we are connecting to the network. What this network switching subsystem consisting of? This network system is a switching subsystem consisting of another set of components, which will be considering, which will be noting about, or which is going to be recording or logging about the subscriber details. It is going to be logging about the subscriber details. It is going to be consisting of VLR, HLR, EIR, AUC, and the corresponding OMC. So what are these things? Why they are being, what they are for? VLR is the visiting location register, HLR is the home location register, EIR is the equipment identity register, and AUC is the authentication one. So what you are having, we are having the mobile, mobile switching center is there through which our BSC is being connected with, and we are also having the visiting location register and home location register, EIR, that is equipment identity register, and also the authentication center. So what they are doing, they are going to be doing, every component present in the MSC is going to be storing about the subscriber information. Home location register is going to identifying that from where the call has been raised, who is that particular subscriber, what is his identity, whether it is been a roaming call or a local call, from where he has been raised through, all his information, what is it, his network, who is with which network he is want to communicating, everything is going to be recorded with the HLR. Subscriber information will be stored. That is nothing but the home location, from where the call has been raised or originated. All that information will be stored in the HLR. And coming to the VLR, that is nothing but the visitor location register. It is going to be storing both the temporary and permanent subscribers of that particular network, both the temporary and the what is called as permanent subscribers of that particular network. So what it is doing is, it is going to be logging the details of whether they are being promptly getting into the network, or whether they are original subscribers of that particular network, or being switched because of any crosstalk, or whether it is because of any switching or because of any shifting, whether the users are being coming in, how you are being connecting to. For example, if you say, if you are being connecting to any Wi-Fi, or if you are being connecting to any hotspot, so you will be the temporary users of that particular network. You will be the temporary users of network. For example, the person who is going to providing the hotspot for you, or person who is going to providing the Wi-Fi for you, that person will be the permanent subscriber of that particular network. So that it is going to store both the data details, like temporary subscribers data will be stored in the VLR, and also the permanent subscriber of the VLR. For example, if you are going to be using your lab, if for example you are using your lab in the department, so in the lab you are being the permanent subscriber of your lab. That is the IT department students will be the permanent subscribers of the lab. You are being continuously using the lab for your own lab purposes. Whenever if you want to work in the laboratory, you can go for and you work with. For example, other branch people also come to your lab for a training purpose or for uses of the laboratory and whatever it is. They will become the temporary subscribers. So both are going to be loaded with the data in the logbooks. So every time you are going to be logging or getting into your lab, you are being signing in the log register. So that particular register will be similar to this particular VLR, which is going to store both the permanent subscribers and also the what is called as temporary subscribers, which are being existing in the network, or which are being connected to the network. And coming to the EIR, equipment identity register, here it is going to identifying the data that is related to the equipment, that is whether the call has been perfectly done between both the subscribers, whether it is a authorized call or unauthorized call, through which you have been identified, whether there is a problem in connection, or whether there is a problem in calling or getting the data, and what is the fault in it, whether it is any fraud call, or it is a liable call or authorized call. All this, or whether there is a troubleshooting procedure, whether there is a problem in the connectivity, whether there is the problem in the data conveyance. All these things will be identified. Equipment identity register or identity, whatever it is going to be taking care of diagnosing or tracing or troubleshooting of your connection, right? Authentication center, it is nothing but identifying about whether you are being the authorized person or not, what is your identity, how you are going to identify it, what is it's your registered identity possibility, how it could be identified, all your authentication details, whether they will be the temporary subscribers or maybe the permanent subscribers, all the authenticity is going to be identified using the AUC. Right. So that is about the equipment of the NSS through which you are been connecting with the local network or the own original network, or you are going to connecting with the other network or switching with that particular other network. These components are been doing your service. And coming to the another one, OSS section, that is the operating subsystem. This particular operations substation or the subsystem is the one which is going to be controlling both the RSS and the NSS, we can say. So without that particular OSS, okay, we couldn't do any operation of within the NSS or the RSS. That is, RSS is going to be responsible for maintaining the OMC. That is nothing but the operation and maintenance control. It has been responsible for maintaining the both the operation and the maintenance of the both the systems, that is RSS and also the NSS. Right. That is what we have discussed in the previous class. These are all the details. Home location register is taking care of the call forwarding, roaming, location information, activity status. Visitor location register is taking care of all the permanent and temporary subscribers. Authentication is about confidentiality and the encryption procedure. Equipment identity register, finding out the stolen data, unauthorized or defective mobile stations. Mobile switching center is for processing of your calls. Radio subsystem is for connecting with the calls of your radio frequency signals from both the OSS and the NSS. And base station subsystem is under the control of the BSC, connecting the signals between the BTS and the BSC. BTS is nothing but the base transceiver system. Okay. So it is going to be handling the OMC. OSS is going to be handling the OMC here, operation and maintenance center. So mobile station is going to be provided with certain data, giving with some smart card, having an identity of subscriber identity module. That particular smart card will have an identity of a number called as subscriber identity module, that is a SIM. Okay, it is about the personal mobility and personal identification. It has also been given some unique identification number that is called as IMEI and IMSI. That IMI is nothing but the International Mobile Equipment Identity, which is given for the device, whereas IMSI is for the International Mobile Subscriber Identity, whereas the subscriber identification is given through the IMSI. And coming to the radio interface. So the most interesting interface is nothing but the corresponding external interface through which we are being using the mobile. That is nothing but from our mobile, how you are being sending the signal. By using the radio interface itself, you are sending the signal outside to the BSS, or sorry, what is called as NSS, and then forward to the OS. So with the help of the OS itself, both the RSS and the SS are been working, but how the signal goes out of it. So using this particular radio interface itself, you are going to be sending the signals. Okay, so by using the antennas itself, we are transporting the signal, wave propagation and all those things. But where the signal is being transmitted, how the radiation will be done, I mean how the radiation of your radio signals will be done in the air, what happens in the actually the GSM signals. So how the data frame or the data packets will be conveyed from the source to the destination. Okay, that is what we are going to be discussing here. Already we discussed that how the GSM has been using the signals, how the GSM is accommodating that much number of radio spectrums of signals or the radio bands of signals to accommodate much of or more number of users at a moment. So that what sort of what is called as accessing procedure, what sort of accessing procedure is going to be followed by the GSM, so that we can accommodate much of the channels. Already we decided that it is going to be having the 124 channels, 124 of FDMA channels, which are being again divided into the 8 TDMA channels of each 124 channel. Okay, so how it is going to be dividing, how it is been accessing, how it is been accessible by the users for various purposes, we will see through, right? So how this particular GSM is going to be capable of accommodating that much number of users. how that particular 124 channels are being used by that particular GSM to accommodate this much number of people. That is 800 million people are being using the GSM around the globe from the 190 countries. So how this particular 190 countries people in number of 800 million are going to be accommodating only into the 124 channels of FDMA, having the TDMA access within them, having only 8 carriers for that. That is 124 into 8 is being possible only with. But how could be it will be possible for accommodate 800 million people can parallelly communicate with each other? That is what we can see now. So this is the actually GSM that is already I've been discussed in some class, dividing that 124 channels. It is 124 channels in a frame. That is 124. This 1 and 2 and 3 and 4. There will be 124 channels for us, which are of frequency division multiple axis. Frequency division multiple axis. Already I drawn for you. I have drawn you. I have shown you. I illustrated you 124 channels that are been divided with some FDMA. Each and every channel has been divided again with the TDMA axis. That is what they have given here, which is called as GSM FDMA and TDMA frame. It is going to be using both the axes. The total channels have been divided into 124 on frequency basis, and the channel has been internally interleaved with TDMA axis. The channel, each and every channel, each and every frequency accessory channel has been interleaved again internally with the what is called as 8 radio carrier frequency signals in TDMA, right? So this is what they have been illustrated here. This is one FDMA channel and this is another FDMA channel of the GSM. So what this FDMA channel is of 125 channels here, sorry, 905 to 960 megahertz of frequency range, 905 to 960 megahertz frequency range of 124 channels. Each channel is accommodating 200 kilohertz. This is for downlink, right? And what about the uplink? Uplink has 692 to 915, sorry, 890 to 915 megahertz, 890 to 915 megahertz, again 124 channels of accommodating 200 kilohertz each are for uplink frequency. So here the total 2 frequency channels are here, there, frequency spectrums are there. Each spectrum is having the 124 channels, okay. Each spectrum is having 124 channels, each of 200 kilohertz for downlink, and it is uplink. That is, these two are for only one frequency spectrum band. These two are for only one frequency spectrum band, among which each and every frequency band, this particular frequency band is again divided into TDMA frame. Each frequency channel, that is each channel, is again divided into GSM TDMA frame. What that particular GSM TDMA is going to do, it is going to be dividing again into 8 radio carrier signals or radio carrier channels. The TDMA, these 8 channels are of the TDMA axis and 124 channels are of FDMA axis. On the FDMA, we are superimposing the TDMA. On FDMA, we are superimposing the TDMA, right? This is what this particular each and every TDMA channel, TDM frame consists of. Again, the TDMA is consisting of, the TDMA frame is going to be consisting of 8 channels. What each and every TDMA frame consisting of? How the TDMA frame is going to be conveying the data for you from source to the destination. Why? Because each and every channel is, this is one channel, this is one, totally 8 channels are there. What each channel is going to be giving you. Why? Because everything has been divided across a time interval, right? As it is the time division multiple axis frame. 1, 2, 3, 4, 5, 8 time intervals will be there. 8 time intervals will be presenting on single frequency channel. Okay, a single frequency channel consisting of 8 time division channels. And again, how many number of frequency channels are there? 124 frequency channels are there for one uplink frequency band. So 124 into 8 total available accommodating of the users, right? So this particular GSM time slot, this is called as a normal burst. We'll see what are all these bursts and what is normal burst and what are those things. So this single GSM time slot consisting of a guard space on either side of it, it can be also called as guard burst. It is consisting of a tail, consisting of a two tails on either side of it, user data, some carry called, some bit called as or a flag called as is here, and in between training data, and again user data. This user data is going to be separated by the training data by this particular S values. What are these S, what are these tails, and what are these guard spaces, and all those things we'll see later how they are being helpful for us, what are all these for. Right. So single TDMA frame occupied by 8 channels are totally occupying how much of time? They are going to be occupying up to only 4.615 milliseconds. 4.615 milliseconds only. Totally 8 channels are going to be sending you the data in a time slotted way or time division way in only 4.615 milliseconds. So again, this 4.615 is been divided into 8 slots, right? So what are those 8 slots to give you totally 4.615 milliseconds? See here, the GSM time slot has been divided into 2 guard spaces, 2 tail spaces, 2 user data separated by the training data, distinguished by 2 S bits, right? So tail data is occupying 3 bits, user data is occupying totally 57 bits, 57 into 2, and training is of 26 bits, and 2 signaling bits or whatever it is, or separating bit and whatever it is between the user data and the training data, right? So totally how many bits are there? 61, 62 and 65. 65 plus 26. What is that? 65 plus 26. It is 91. 91 plus 57. 91 plus 57, it is 148. Totally 148 bits are going to be carried by this particular GSM TDMA frame. And what this single GSM TDMA slot occupies? The total divided data, that is only the exclusive time slot, that is the without the guard spaces, it is going to be occupying 546.5 microseconds. 546.5 microseconds. And along with the guard spaces, how much of time it is going to be occupying? 577 microseconds. So 577 microseconds into 8 will be giving you the 4.615 milliseconds. 577 microseconds into 8 will give you the 4.615 milliseconds. So each and every channel of 1 to 124 channels, each and every channel is consisting of the 8 radio carrier channels of TDMA, and each and every TDMA channel consisting of 8 channels. Each and every channel is going to be occupying 577 microseconds of a guard space. Along with the guard space, this 8 into 577 microseconds will be leading us to the 4.615 milliseconds. Right. This 124 into 4.615 millisecond. 124 into 4.615 milliseconds. 124 into 8 channels. 8 into 4.615 milliseconds. In that way, it is going to be accommodating that much number of users into your frame. I think I am clear now. I think already noted you this particular frame. Everybody please note this particular frame so that you can identify that how these mobile service providers, mobile network providers, all are going to be accommodating this much number of millions and billions of users into their frequency band of spectrum. How those are going to be accommodating this much number of people. Everybody is going to be using 3 to 4 networks at a time, and all are going to be using their own channels and own networks for their own purposes. That is because we are going to be using the Airtel, we are going to be using again the Geo at the same time, and you are going to using another phone for accommodating another 2 SIMs. Totally 4 networks are being used by us. So how this particular people, that is why, because you are going to be using, or you are going to duplicating in the same network, and you are also duplicating in the another network also. Yourself you are going to be duplicating. So how many duplicates are comes in, how many number of users will be there, assume how much of cumbersome of of users for each and every provider networks, how they are being accommodating you, how you are going to be parallelly doing. You are not going to be making a single single call, you are going to doing the group calls, you are doing the conferencing, video conferencing, audio conferencing, everything you are going to be doing. How all these are going to be accommodating. So once you understand this particular frame, how it is been accommodating that much number of channels in the time slots and frequency slots, you can understand what is happening and how the number of people are going to be using the same frequency band in the same generation, either in the 2G or either in the 3G or in the 4G or in the 5G. So what is happening and how you are going to be doing all these accessing or multiplexing among the number of users, this can be understood, right? So please note down this diagram and please see that whether you have been understand or not. If you couldn't understand what is going to be happening, I can explain you again how the people or how the users are going to be accommodating in these structures. See, I'm again just giving a review that this is the GSM frame within which you are going to identifying this particular frame has been divided into 124 channels on the frequency division multiple axis. These are the two frequency bands for a single channel, right? And frequency band, these are the 124 channels for a single frequency band of spectrum, 124 channels for downlink, 124 channels for uplink, but two frequency bands will be used. Okay, each and every channel will be occupying 200 kilohertz, and that particular channel is consisting of internally again the 8 TDMA channels within it, and each and every channel is going to be again divided among the different time slots, and that particular time slot is of 577 microseconds. All these 8 channels will be combinedly taking 4.615 milliseconds. This is of only one single channel. A single channel is occupying 4.615 milliseconds, and 4.615 milliseconds into 124 taking how much of time for uplinking, and again 4.615 milliseconds into 124 for the downlink. And this is of this is of only for the corresponding a single frequency band of spectrum, both for downlink and uplink. So what about the other frequency bands? All those frequency bands are also again having 124 channels, both for the uplink and downlink, and all those other 124 channels of both uplink and downlink will have again the TDMA sleevings or TDMA interleavings, right? This is how the frame is going to be accessing. So this is what they have been said. Here what you are going to, so saying that is how you are being calculated, that is of 148 bits occupying, right? So 546.5 is for actual frame, whereas 30.5 microseconds are for guard space, right? So here they have been given for us the first and last 3 bits of a normal burst has been given as a tail. All are set to 0, used to enhance the receiver performance. That is between to identify the difference between the one frame to the another frame, you are going to adding this particular tail bits in the frame, which are of 3. All are being set to the 3 zeros itself. Those tail bits are going to be giving you the distinguish between the one frame to the another frame of data. And coming to the training sequence, whatever the between the user data, you are having the training sequence of information. What is this training sequence of information is? This is going to be adapting for the parameters of the receiver, whether the current path propagation characteristics, and select the strongest signal in case of multipath. For example, if the information has to be not only sent to the single receiver or a single destination or whatever it is, if the sender or if the receiver or the target is not a single one, or if it has to transmit over the number of paths, number of users are there, if the destination is multiple in number, in that what is called as, in that case of transmission, that is one to many or many to many transmission is there, in that case you are going to be using this training sequence to identify what are all the propagation characteristics of different paths in which the signal has to transmit. And coming to this, a flag is, I already told you that S may be of the flag indication. It is indicating whether the data field consisting of contains user or network control data. So if the frame that has been sent over TDMA is the user data or any network synchronization data, that can be identified using the flag bit, right? So the total TDMA frame is consisting of guard space, that is to protect the frame, and tailing bits which are going to use it for identify or to have the receiver performance to distinguish the different frames of data. Okay, usually they will be set to 0 itself, and there will be a training sequence in between the two sets of user data that we saw in the frame, so that that particular training sequence is to give you the propagation characteristics and the path characteristics if the propagation of the data or the transmission of the data is the multi-transmission information or the multi-transmission propagation, so that the training information will be there, that in which path data has to be transmitted, how it has to be transmitted, all those things will be in the training sequence as the name implies. And the S bits in between the training sequence and the user data, which indicates whether the information is related to the user information, that is the TDMA frame is related to the user or to the network, that will be identified using this flag. Okay. So using along with this particular normal burst, one second. Along with this normal burst, it is also going to be providing you another types of burst according to the European Telecommunication Standards Institute. According to the ETSI, that is nothing but European Telecommunication Standard Institute, along with the normal burst of information that has been carrying over the information along with the frame in the TDMA, it is also providing you another sort of burst. What are those bursts? Are nothing but a frequency correction burst. A frequency correction burst allowing the mobile station to correct the local oscillator to avoid the interference from the neighboring channels. See, all the channels are being one another by side they are being situated. That is, 8 channels are being or side by side they are being existing, so that without having the interference from the local channels or the neighboring channels, this particular frequency correction burst is going to allowing the mobile stations to avoid or to correct the local oscillator of that particular frequency. Why? Because all these 8 channels, 8 TDMA frames are going to be set in a FDMA frame, right? All the 8 TDMA frames are set in a or holded in a frequency division frame, so that the frequency oscillator has to be get corrected if they are going to be getting overlapped, or either neighboring channels are going to be disturbing you, or your data is going to be getting disturbed by the neighboring channels. In that case, this particular frequency correction burst allow us to rectify that particular interference. And next one is a synchronization burst will be also there, which is going to be identified. It will be an extended training sequence to synchronize the MS and the BTS. That is, the mobile station and the base transceiver system are going to be get synchronized with each other with reference to the time using this particular synchronization burst. Why? Because whenever a signal or a call has been raised by the mobile station, then it has to be get synchronized with the, then it has to be what is called as get connected with the base transceiver system. With the base transceiver system itself, it has to get out of the base station controller, so that they has to get synchronized with each other. For that one, you are using the synchronization burst. Next one is the access burst, which is to get or provide an establishment of a connection between the MS and BTS. This is the one which has been first raised to have a connection between the MS and BTS. That is the access burst, using which you are going to accessing both these things, mobile station and the base transceiver system. Base transceiver station has to be get established a connection between them using the access burst. After that, once the transmission goes on, that will be get synchronized by the synchronization burst. And if there is any interference with the neighboring channels, it will be get synchronized by the frequency correction burst. Finally, a dummy burst will be also added with the TDMA frame. A dummy burst will be also added to the TDMA frame if there is no data available for a slot. If there is no data available in among any one of the channel in the 8 channels, then you are going to providing with the dummy burst in that particular channel. Every time the channel will be live in this, it is going to be enabled. Okay, whether it is consisting of the data or not, it's not a case. But if it is not consisting of any data or any user data, simply it has been set with the dummy burst. Otherwise, along with the normal burst of information, it will be get connected, it will be get added with the access burst, synchronization, but the synchronization burst and the frequency correction burst. If no user data is available in that time of interval in that particular TDMA channel, then you are going to inserting a dummy burst. Okay, that is the case. Next one is, so there you are going to be ended with the channel and the TDMA frame, right? I hope all of you have been understood what is this particular TDMA and how the data is going to be inserted and all these above. And how these channels, different types of channels are there, different types of frames will be there, what are all the different physical channels and the low controller channels and the frames accessible and used by the GSM, so that your data will be transmitted from your source to the destination without any interference, without any loss of data, without any what is called as crosstalk, without any loss of data. All these are going to be happening. There are different types of channels are there. Physically existing channels which are transmitting the information, control channels will be there which are synchronizing this particular physical channels, logical channels will be there which are inducing certain types of burst into your physical channels to standardize your transmission of your data, and frames, different frames will be there which are dividing the channel into the sections, right? We'll see what is the physical channel, what is the logical channel and all those things. So physical channels are control channels and logical channels in the frame hierarchy of a GSM. So what is a physical channel? It has been defined by both the carrier, signal and both the carrier frequency and a TDMA slot number, time slot number, right? This will be the physical channel where it is been specifying both a carrier frequency and a TDMA time slot number. So that is nothing but what you are been calling as 8 channels. All those 8 channels will be allotted with a carrier frequency number. That is what sort of carrier frequency it has to hold by that particular TDMA frame. It will be identified, and also a TDMA slot number will be given. So physically you could identify what is the TDMA slot number and what is carrier frequency. Then you can say that particular channel is the physical channel. If any channel is having a carrier frequency number and also a TDMA time slot, then you can identify it's a physical channel which is transmitting your data. Next one is logical channel. What is this logical channel? These logical channels are multiplexed into the physical channels. Each logic channel performs a specific task. So these logical channels, what they are doing is, these logical channels are being divided or multiplexed into the physical channels, depending upon the requirement of the users and requirement of the data that you want to transmit. How many number of users are to be get accommodated? How many number of channels are required at that moment? How many number of signals are to be transmitted? Depending upon that, depending on the availability of the total frequency, we are going to be first deciding them into the logical frames or the logical channels. After that, those logical channels will be divided into the physical channels according to the frequency of the data or the information that we want to send. Right? As we see, the frequency band spectrums are divided into the time band spectrums. There will be if you see as a whole, you can say that all the total spectrum of the GSM will be firstly available as a logical channel, a set of logical channels. All those logical channels will be grouped or divided or interleaved into the physical channels according to the transmission. For example, if you need a 10 channels to transmit the data, if the logical channel is consisting of 100 as a spectrum, then among the 100 logical channels of spectrum, your 10 channels will be separated for the transmission of some user. That is what the difference between the physical channel and the logical channel. All the time the logical channels will not be enabled for the transmission. Only the physical channels are enabled for transmission of your data. They will be live. Physical channels will be live, logical channels will not be. They may or may not be, right? That is about the physical and the logical channels. And coming to the frame hierarchy. See, TDMA frames, the frame hierarchy, how the frames are being arranged in a separate hierarchy. Why? Because every time the frame will not be of the similar category. The frame will be arranged. It is organized according to the requirement what I have said now. Okay, so how this particular frames will be hierarched, how they have been arranged in an hierarchy, what they have been grouped, so how they will be used for different purposes. So the TDMA frames are grouped into two categories, two types of multi-frames. One is 26 frame multi-frame and next one is 51 frame multi-frame. That is, you can organize the data either in the 26 frames or in the 51 frames. What? You can organize or you can send the data in 26 frame multi-frame or 51 frame multi-frame. We already know that each and every frame is of 4.615 milliseconds occupied. Okay, that particular frame consisting of 8 radio carrier channels. So 4.615 milliseconds into 8 into what you are saying here, you are sending the 26 frames per a multi-frame. That is a multi-frame of 26 frames with a net. A multi-frame of 26 frames with a net, and each and every frame is consisting of 8 channels occupying 4.615 milliseconds, right? So 8 into, right? 8 into 8 or 8 into 26 here. Totally 120 milliseconds it is going to be occupied. Comprising of 26 TDMA frames, we know that. Comprising of 26 TDMA frames, 26 TDMA frames are going to have each and every 26 is going to have 8 channels internally. This multi-frame is used to carry traffic channels and their associated control channels. So what this 26 frame multi-frame will be used for? Either for carrying the traffic channels or associated control channels also. Why you are been arranging them in a multiple, not as a single? See, each and every, we are having the 124 channels, right? 124 FDMA channels. Among the 124 FDMA channels, each and every channel is having the 8 TDMA frames. Among the total 8 TDMA frames, how you are been arranging in so? That is, you are picking a big shopper consisting of all the goods in it. So each and every carry cover or carry bag is going to be keeping in the total big shop here. What you are doing here, we are having a TDMA frame of 8 carrier channels. That is the normal carry cover we are having, and that particular normal carry cover you are keeping it in the particular multi frame, which is called, we are calling as a big shopper, into called as 26 frame or a 51 frame. That is accommodating the 21 channels or the 21 frames in 26 frames into a single frame of a multi-frame, what you are being called as. Or you can also arrange 51 frames into a single multi-frame, right? Simply you are accommodating 26 TDMA frames. Simply you are accommodating 51 TDMA frames in these two sections, occupying 120 milliseconds in 26 multi-frame, 26 frame multi-frame, and accommodating 235.4 milliseconds in 51 frame multi-frame second. That is double of it, almost double, more than double, right? So they are therefore carrying both the traffic channels, whereas 26 frame will be exclusively for, it will be used both for the traffic and control channels, associated control channels, whereas 51 frame will be exclusively used for the control channels, only to convey the control channels. What are these control channels, ma'am? What are these traffic channels? What they are being conveying you in the transmission of the data? We'll see what are these traffic channels and the control channels later on. Right, and along with this multi-frame structure, we are also being provided with the super frame. Along with the multi-frame, we are also having the super frame structure also. A duration of 6.12 seconds. 6.12 seconds. What this is being consisting of is the multi-frame structure is further multiplexed into a single super frame. It has been again multiplexed into a single super frame, duration of 6.12 seconds. What the super frame consisting of? Super frame consisting of 51 multi-frames of 26 frames. So how much of users and how much number of channels you are being accommodating? See or assume that how they are being internally getting congested with each other. Even though they are being getting congested or accommodating with each other, they are carrying your signals very exclusively, very sensitively, and very clearly. How many number of people are being talking with each other? How many number of people are being conveying or transmitting the data with each other or exchanging with each other? Nothing will be getting lost. Everything will be clean and clear. Everything will be crystal clear of audio will be feasible to you. I am talking with you people. Totally 95 people are being accessing with me, but I am able to give you the information very clearly. Everybody are being hearing us, hearing me. Everybody are being getting to see whatever I am displaying here. How it has been possible? How it has been possible because of the super frames, because of this multi frames. So if the super frame may be consisting of 51 multi-frames of 26 frames or 26 multi-frames of 51 frames. If you can accommodate like this, If you can accommodate like this, 51 frames of 26 multi-frames or 26 frames of 51 multi-frames, it will become a super frame for us. It will become a super frame for us. Each and every super frame is going to be occupying 6.12 seconds. See, until now you are going to be talking about only the microseconds and the milliseconds. Now you entered into the seconds. Now you are entered into the seconds now. So that occupying much of users, occupying multiple number of frames. Okay. See here, again another one is the last multiplexing level of the frame hierarchy consisting of 2048 super frames. The last multiplexing level of the frame hierarchy, 3DMA frame hierarchy, consisting of 2048 of super frames. 2048 of super frames is nothing but how many number of things here? 27 lakhs 15,648 TDMA frames will be holded by this particular multiplexing level of the frame hierarchy, which is called as hyperframe then, which is called as hyperframe. See, all these frame hierarchy can be illustrated in a single picture, which can be discussed in the next class. So we'll have a clear picture. Just we discussed about the frequency band spectrum divided into the 8 carrier channels simply, right? But how that particular internal carrier channels or the radio channels or the TDMA channels are being internally slotted and internally arranged with each other to accommodate these much number of 800 million number of users. So how that particular 800 million number of users could be accommodated into this particular frame hierarchy of TDMA of GSM. Right, we are having the 8 frames. Within that we are having also have the chance of multi frames, and we are also having the chance of super frames. We are also having the chance of hyper frames. So using these hyper frames, super frames, multi frames, and also normal frames of the TDMA, we are accommodating that much number of users to get communicate with each other very clearly, right? So we'll see this particular picture, right? Having the hyperframes, superframes, multiframes, accommodating this much number of users into a single channel and discuss in the next class. Thereafter, we'll discuss with the logical channels, traffic channels, channel hierarchy, control channels. All those things can be discussed in the next class. We are run out of time, and yeah, it's time for attending the next soft skills training. So I'm leaving here. Right? Please refer through the topics every time, every day, because that particular subject is very much of interest and at the same time confusing also, right? So please be clear every time before continuously to avoid the confusion. So once you've been fixed a particular design or a particular path of studying, then you are not getting confusion at any time. So that once you are been referring continuously, you'll be having a particular plan of design and a particular plan of whatever the topics that you are being discussed from time to time. So you'll not be able to confusion at all at any moment, even in your sleep also. Okay, so please continuously refer so you won't get the confusion and you are being able to write at any time or you're able to answer at any time, right? So I'm leaving the session. Thank you.